This is one we finished up with yesterday. We said it was so much fun, and I gotta get going on the next one. All right, so we're still sketching graphs today. This is the third installment on section 3.5. So this is 3.5, the third part. All right, just as a quick review, when we're doing these, we have certain criteria we have to do. First, what is the x-intercept? Usually you get that by graphing or factoring this. So in this case, let's factor it and see what we come up with. Let's try to factor everything. So that should be x squared minus 2x plus 14. 2 and 7 doesn't work. I'm tired of playing with it. So I'll just go to the program. So I can quit, clear, program. I'm just looking for the factors, see if there are any. Let's see. X squared is 1, negative 2, and 14. So it's imaginary. So there is no x-intercepts. Okay? No, I don't. So no x-intercepts. It doesn't factor. So that's kind of good. And the bottom, we'll factor it. X squared minus 2x plus 14. The bottom factors into x times x plus 3, x minus 3. Okay? So, x-intercepts, none. 2, the y-intercept. If I put 0 in for x, I get 14 over 0. So there's no y-intercepts either. Number 3. What is the, let's see, x cannot equal 0, x cannot equal 3, x cannot equal negative 3. And those are all going to be vertical asymptotes because the top doesn't factor. Vertical asymptote, vertical asymptote, vertical asymptote. The top doesn't factor, so that's taken care of. Horizontal or oblique asymptote. Horizontal or oblique. Let's see, that would be the degree of the numerator is 2, the degree of the denominator is 3. Horizontal at y equals 0. Okay? Because the degree of the numerator is bigger than the degree of the denominator. Now, to see if it crosses, you set it equal. X squared minus 2x plus 14 all over x cubed minus 9x squared. Cross multiply. We already know there's no solutions to this equation because we did earlier. So we know it does not cross. Nay, no crossing points. Okay? So you make your sketch. No x-intercepts because there is a horizontal asymptote at y equals 0. Okay, check. There is no y-intercepts because there's a vertical asymptote at x equals 0. Vertical. Oh, I kind of like that, the red and the blue. Ha! 3. 1, 2, 3. 1, 2, 3. And dun, 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 dun. All right. Now you have all these regions to check. I could do the x approaches, x approaches, x approaches, but I don't feel like doing that today. Today I'll just simply get some practice graphing it on the graphing calculator. That's a skill that a lot of people still are having problems with. So I'm just going to graph it out and see what the intervals look like as far as this graph goes. So remember, I have to group the numerator, x squared minus 2x plus 14 divided by x cubed minus 9x Okay. I want my standard screen. Okay. And from that picture, I should easily be able to tell how to make my sketch. Okay. So I can tell that the graph is going to be very close, and it's going to drop right here. I know the graph is going to come down somewhere, go back up, something like that. I know it's going to cross and go back down. And I know it's going to end up something like that. Okay? I didn't feel like doing the X approaches today. I want to do some more on the graph so you can see where the asymptotes were as far as how the graph behaves for the horizontal and the vertical asymptotes. Okay? So, with that said, that is how to read a graph to make your sketch. All right? Okay. Before I forget the homework that I have to get to, 264, 27 through 49 odd. So that's my goal today. And also you're going to have a homework check over section 3.4. All right? So, moving on. Another practice problem. Find the oblique asymptote and sketch the graph of F. All right? Well, if we're going to sketch the graph, we're just going to do it like always. Excuse me. We're going to answer all the questions, and it'll come up as an oblique on its own. All right. So, I'm going to factor it this way. 2x squared minus x. Let's see. 2x squared minus x minus 3. So it factors into -1 and 3/2. Okay? So this is going to be x plus 1. Said -1, didn't it? Yeah. And then 2x minus 3. All over x minus 2. All right? X-intercept. I'll just start at the beginning. X-intercept is going to be at -1 and 3/2. Y-intercept. You put 0 in for all the x's, you end up with a positive 3/2. Interesting. X and Y have the same intercepts. 3. X cannot equal 2. And if I put 2 in, I end up with some number over 0. Some number over 0. So that tells me there's a vertical asymptote at x equals 2. Number 4. Horizontal or oblique asymptote. The degree of the numerator is larger than the degree of the denominator. So that tells you it's an oblique asymptote. And the only way to find an oblique asymptote, I told you, is the quotient after you do long division. So, long division it is. Yeah, you could do synthetic division since you have a 2 on the bottom. You could do it like that, or you could do long division. Oh no, I just always do long division. You could do synthetic. Since it's a linear factor, you can do that. 2x squared, but I'm going to do long division, old school. So x goes into 2x squared 2x times 2x. So I have 2x squared minus 4x. Remember, you have to multiply this through to both of them. I subtract. 2x squared minus 2x squared is 0. Negative x plus 4x is 3x minus 3. And how many times does x go into 3x? Well, yeah, 3 times. 3x minus 6. You don't really worry about the remainder because it's not going to be graphed. So there's your oblique asymptote. Y equals 2x plus 3. Okay. Oh, I have to check on both sides of the asymptote, see which way it's going. Okay, if I put a number like as x approaches 2 from the left, that'd be like 1.9, be positive, positive, negative. So it's going to approach negative infinity. As I approach 2 from the right, up here like 2.1, Be positive, positive, positive. So approach positive infinity. Okay. I think we're ready. Let's make a sketch. Oh, does it cross? Let's see if it crosses the oblique asymptote. Okay. Oh, this is going to be hard. All right. Let's see if it crosses. Let me get a picture here of this to drag it down so I can see it. I have to see if it crosses the oblique asymptote because it can cross. Will this ever equal 2x plus 3? That's the equation for my oblique asymptote. Well, you cross multiply 2x squared minus x minus 3 equals 2x squared x minus 2. 2x squared minus 4x plus 3x is minus x. And then 3 minus 2 is minus 6. So I subtract the 2x squareds off, subtract the x's off, so no, it does not cross the oblique asymptote. Okay, negative 3 does not equal negative 6. Now I'm back to graphing. Negative 1 and 3 halves for x. Y-intercept, 1.5. At 2, there is a vertical asymptote. There's a horizontal asymptote at the line 2x plus 3. So there's 3. And then I make the dot going up with a slope of 2. 1, 2 over 1. So it looks something like this. It's got to hit right through there. It doesn't have to hit there. Okay. So there's my equation of my oblique asymptote. So it's going to follow that at the end of the graph. And on the left side of negative 2 is negative infinity. And on the right side of 2 is positive infinity. Okay? That's not a very good sketch. That's a little bit better. I'll just move it out of the way. So the graph is actually going to come from down here, go up, hit, 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 go back down on this side, and then up here at the top, it's just going to hit and take right back off to this side. Kind of a weird looking graph. Okay? So that's your sketch. Okay? You have all the points in the information over here, and you have your graph over here. Okay, so today we'll just check it out. I'll go over here and take a quick look at it. Y equals. I need parentheses to group the numerator. 2x squared minus x minus 3 divided by x minus 2. And then I graph it. Zoom 6. I forgot where I was at. Okay, so I have this part, but I don't have the upper tail. Well, that's because my window's off. So I have to change my window. Window. How do you know that? I don't know. Just go up to, say, 30 and see if you see it. Graph. There's that bend. Oh, there it is. See? Yeah. So now you have a visual confirmation of how the graph compares to that one. Okay? Yeah, so yeah, it looks pretty good. You see the oblique asymptote, the vertical asymptote, where it crosses the axis. Yeah, so that's good. Now remember, some classes you won't have a calculator and some you will. So it just depends on where you're at and what you're doing. Okay? All right. So, moving on to the next one. That was an oblique asymptote. Okay, 2x plus 3. This is a big section, by the way. I'm just looking in the book, see where I got to go. Oh, okay. I got to do some more stuff. Sorry. Why won't that go away? Auto hide. I don't understand what's happening. All right. That still works. I'm stuck. There we go. Phew. All right, let's just go with it like that. See if I can do something. Find the oblique asymptotes and sketch the graph of the function f of x. Okay. Let me try something real quick. Try to get it back. Okay. There we go. See, I'm a genius. All right. So, find the oblique asymptote and sketch the graph. Yes, start at the beginning and work your way through it. That's all there is to it. I can factor the numerator. Everybody remembers how to factor a perfect cube, don't they? I guess you don't have to factor it if you don't want to. I mean, everybody knows that the x-intercept is going to equal -1. Everybody knows that the y-intercept is going to equal -1/9. Everybody knows that x cannot equal 3 and -3 because that's going to be a vertical asymptote. Okay? Did I skip a problem? No. Okay, good. Vertical asymptote, because it's going to be like 28 over 0 and -26 over 0. All right? So we got vertical asymptotes for that. Number 4, horizontal or oblique. Well, the degree is 3 and the degree is 2, so x cubed plus 1 goes on the inside, and x squared minus 9 goes on the outside. X squared minus, no, the other way around. Made 2 mistakes and same. Yeah, I know. It's been a long week. X squared minus 9, x cubed plus 1. So, how many times is x squared going to x cubed? That's easy. X times. So I have x squared minus 9x. X cubed minus 9x. Subtract. Subtract, so I end up with 0 minus, let's see, that's going to be a 0. 0 minus the -9x is 9x. I bring down the 1. And this degree is higher, so that's it. That is your oblique asymptote right there. Okay, y equals x. Does it cross? I don't know. Let's find out. X equals x cubed plus 1 over x squared minus 9. So, I multiply, cross multiply, x cubed minus 9x equals x cubed plus 1. Those cross off. X equals -1/9. So it does cross the oblique asymptote at -1/9. Okay? So that takes off. The action of the graph around -3 and 3, I'll just use the graph for because I'll double check it. I want to make sure everything looks all right, especially the oblique asymptote. Here's my x and y axis. Here comes my x-intercept at -1, my y-intercept at -1/9. Very small graph right there. Verticals at 3 and -3, 2, 3, and -3. Okay. Oblique asymptote at y equals x. Okay. I can already pretty well tell what the graph's going to look like. I'm sure you can too. And it's going to cross that at x equals -1/9. So I'll put that on there as well. Right there, it's going to cross. Okay? If I had to guess, I'd say the graph is going to look something like this. It's going to go down and come up, do that. It's going to come through here, hit, going down through. If I had to guess, I would say go this way. Okay? Well, you know that because it's not going to cross the x-axis on either outside region. It's only going to cross the x-axis once and doesn't bounce because it doesn't have a linear. It has a linear factor. -1, it's got that cubic look. -1, it's got that cubic look. So all those lead me to believe that's what the picture will look like. And you should be getting some graph savvy of your own to see what it looks like. So let's double check it. X cubed, x caret 3 plus 1, divided by x squared minus 9. Delete and graph. There's the bottom, there's the cubic action, and there's it going back up top. Okay? Yeah, so it looks pretty good. And yeah, we got the oblique asymptote on here, y equals x. Oh, I'm not zoom standard. That's why it looks so funny. Zoom 6. There we go. There it crosses at the cubic. It looks something like that. I use this picture instead of the other one. I can do that. It's my desktop. All right. So you got the y equals x. You got the verticals. You got the verticals. You got the little crossing point at -1/9. The cubic crossing at -1. And you got the y-intercept at -1/9. You have all the information on there. In calculus, you find these points as well. Okay? So you can add a little bit more to your graph than just intercepts and vertical asymptotes. Okay? You can add more and more to the graph. All right? Fantastic. Sketch the graph, simplify it, and sketch the graph. Find the oblique asymptote. I'm looking for something to do. I think I'll do this one. I'm going to bypass this one. I'm going to do this one because I'll work on some more on the obliques. I'll show you how you can use synthetic division. This is a linear factor, linear. So I can use synthetic division on here, okay? So, I know, one, the x-intercept. I don't know what that is. It looks to me like I can take an x squared out of both of them, x minus 2. And it looks like here I can take a 4 out of both of them and get an x minus 2. That leaves me with x squared minus 4 times x minus 2. So I have x plus 2 x plus 2, x minus 2, x plus 2. That's what it looks like to me. That's not your bell, so just hold on for a minute. Okay, check out a 4 and x squared. Yeah, it looks good. You have an x minus 2 right here. Okay, so looks to me like the x-intercept is going to be at -2. Because there's a common factor right there, so it's not going to cross the graph at 2. Looks like the y-intercept will equal, well, I put 0 in for x, will equal -4. Okay. 2. 3. X cannot equal 2, and that would be a hole in the graph. In other words, known as removable discontinuity. And how do you find the y-coordinate? Easy. Once you know it's discontinuous, you cross that off, you put 2 into your result, and what you get out is the y-coordinate. So the hole is going to be at the point 2, comma, 4 times 4 is 16. So there's going to be a hole at 216. All right? Number 4, horizontal or oblique asymptote. Well, we know it's oblique because it's a third degree divided by a first degree. Anytime it's improper, you know it's going to be that, so you have to find the equation of y equals. And I said I'd use synthetic division right now to find it because it's a linear factor. I put 2 on the shelf, a 1, a -2, -4, and 8. 0, 1, 2, 0, 0, -4, -8, -8, 0. That leaves me with x squared minus 4. That is my remainder. Oh, I'm sorry, that's my quotient. My remainder is 0. Okay? But we know it's a hole in the graph because we already took that out. So there's my oblique asymptote. You can do that with linear functions. You'll get the same thing, x squared minus 4. So it's x squared minus 4. Okay? Now you have to see if it crosses. Well, so you take x squared minus 4 over 1, say equal to x cubed minus 2x squared minus 2x squared minus 4x plus 8 all over x minus 2. Okay? And you multiply that out and see what you get. X squared minus 4, x minus 2, x cubed minus 2x squared minus 4x plus 8, x cubed minus 2x squared minus 4x plus 8. Ah! It doesn't cross. All right? So, well, yeah, because the x cubes cross off, the 2x squareds cross off, the 4x cross off, and the 8s cross off. There's nothing left. So it doesn't cross. There's no x values. Okay? So let's put all this into a graph. A sketch. The oblique asymptote is a parabola down there, comes swooping in like this. Okay. The x-intercept is negative 2. The y-intercept is negative 4. 2, 3, 4. And there is a hole in the graph at 2, 1, 2, 16. A hole. 2, 16. Wow, this one really looks weird. I'm going to move it down so I can see exactly what's happening. I think I have all the information. X-intercept negative 2, y-intercept at negative 4, hole in the graph of 216, and the oblique asymptote. Oh, there's no verticals. Okay. So, well, obviously the graph is going to come down here, hit, go through here, and bounce, or something like that. I don't know. I say we graph it out and see what it looks like. I got some of the numbers. Y equals x cubed minus 2x squared minus 4x plus 8. I need my grouping parentheses up there, so I have to insert that. And I need a grouping parentheses down here for the numerator, so I have to insert that. And that's all going to be divided by x minus 2. Okay, zoom 6. This ought to look weird. Well, this is like a regular parabola. Let's see, I'm going to take my window, move it up to 20. Just to double check one thing. It looks like a parabola because it went into it evenly. So it follows the oblique asymptote for all values of x except for second calculate 0 or value at 2. Yeah, there's a hole in the graph at 2. So my graph down here, when I had, this is a better sketch, when I had 0 equals 0, that must be true for all values of x. True for all values of x. Okay? So the only thing you have to do to this is put a little tick mark at 2 and 16, wherever that is. Somewhere around in there like that. Okay? There you go. You got the negative 4. Y-intercept, x-intercept negative 2 is right here. Wait a minute. The hole's at 216. It's going to be at 216. 216. If I cross off, put 2 in there. Well, yeah, it is. 2 and 16. 4, 4, 16. It looks like it should be at 2-0, doesn't it? What is going on? X squared minus 4. If I put 2 in there, I get 0. Oh, it's my factor. There's another x minus 2 right here. Yeah, I heard you. I hear you now. See, that's why you double check it with the graph. Hole's at 2-0. Yeah, if you cross it off, you still have an extra one. Got it. Phew! Thank goodness. All right, so there's a hole in the graph right there. All right. Let's see. I think I wanted to go 30 minutes to give you about 15 minutes for your quiz. So, with that said, your homework is through 49. If you have any questions, I'll answer them on Monday. And for right now, for your homework check, go ahead and do, let's see, your homework is page 264, 27 through 49 odd. Okay? Your homework check is on page 247. And you're going to do problems 7, 14, 21, 24, and 33A. Okay? That's your homework check. Page 247, 7, 14, 21, 24, 33A. All right? Any questions, I'll go through them on Monday. Thanks again. Get started. You should have about 15 minutes. How do I stop this thing? There we go.